Hi, everyone. I've got an interesting update for you today on that situation of the partial bridge collapse in Oldtown, Maine that occurred on August 13th, 2026. I'm recording this video on August 18th. Many of you have reached out with some great insights as well as source information. One of you was obviously a structural engineer and pointed out that you believe, or they believe, that there was a construction sequencing issue, and I'm going to go over this in more detail, but this source pointed out to me that there could be a serious issue with construction sequencing if, in fact, they place concrete inside these composite tub girders at the ends prior to placing the concrete for the bridge deck. And I'm going to go over that in a lot more detail, but that looks like that could very well have been the case here. Now, one concern I have already is that there's a lot of interconnectivity among all the principal players, it seems, or most of the principal players on this project. You have the Transportation Infrastructure Durability Center that gets millions of dollars, tens of millions of dollars of federal funding to conduct research that leads to things like these composite tub girders that apparently have started pulling videos, or at least in one instance, pulled a key video from public viewing from their YouTube channel. It's either been deleted or privated. This was reported on by Maine Public, and I've confirmed that there are bits of the meta tags of this video out there on the internet. So this video did exist up until recently, and the title is FRP Composite Tub Girder Installation for the Stillwater Bridge Replacement, March 2026. So I don't think that's a good look. You've got a university who should be presenting information to the public, the good, the bad, the ugly, so people could actually learn about what happened. And I don't know what potential liability concern they may have had here that would lead them apparently to have pulled their video off their YouTube channel. They also canceled their upcoming conference that was supposed to start August 19th, where they discuss composite tub girder technology as well as other technologies that they're developing at this research center. Why would you cancel a conference? I mean, I understand everyone that goes there is probably going to be talking about what happened with the bridge, but to the extent that you have any ideas or you have certain facts available, a conference is a great place to disseminate it, in my opinion. But I'm not a lawyer, so just draw your own conclusions about that. As I mentioned, I'm going to come back to the details that this structural engineer shared with me about why they think construction sequencing may have been primary culprit here that led to this bridge collapse. Now, fortunately, there are some videos related to this technology and related specifically to this bridge that have not been deleted. I'm going to cite heavily from these two presentations. If you're wanting to check out the entire videos, there's links in the description. A more technical presentation was presented by people with the university as well as the manufacturer of these composite tub girders. And this webinar was hosted by Florida International University. That sounds familiar. They had the tragic pedestrian bridge collapse that occurred in 2018 that killed 6 people. Now, the university developed this composite tub technology and they licensed it to a Maine company, Basalt International. Technically, the girders are manufactured by AIT Bridges, but they went bankrupt and were acquired by Basalt International in January of 2025. See this tout sheet I covered in my previous video. Now, again, from this technical presentation, there were a lot of details associated with this Stillwater Bridge that suffered the span collapse. There are really two segments of the bridge, what they're calling Bridge 1 and Bridge 2. Bridge 1 has a total length of 152.5 feet. It's comprised of two 75-foot long spans, and Bridge 2, where the failure occurred, is a total length of 290 feet. That's comprised of three 95-foot long spans. Each span has 5 composite tub girders spaced a little over 8 feet center to center. The depth of the girders is a little over 4 feet. See a photo here from the Maine DOT website for this project. This is a close-up view of a composite tub girder. Now, going back to what the structural engineer shared with me, these composite tub girders, they're empty inside, but they get concrete infill on the ends and at the center where they go over a pier at a given location. And this is showing the cross section with infill at the ends. And when you have this concrete infill, they've got these shear connections to hold it all in place inside the composite tub girder. And what this structural engineer was explaining to me, you have a camber or a bow in these girders, and the high point is on the top surface. And when you set these girders on the abutment over a pier, you're anticipating the loading from the subsequently placed bridge deck to flatten out or to push down that camber to straighten it out. And when that happens, the girder elongates on its connections. And if you have the ends fixed or they're rigid and they can't move outwards because you've already got your concrete infill there, you're going to have stress concentrations that are going to be problematic and could perhaps have contributed to this failure here. Now, I'm just going by the drone photos. It looks like the infill may have occurred there already, but at any rate, as part of the development and implementation of a technology like this, you would need the designer to specify in very great detail what the installation sequence needs to be. And of course, the contractor would need to follow such an installation sequence. So I'm sure that's going to be part of any forensic investigation as to what happened here. But it sure looks to me like there may be concrete infill already on these end pieces. And of course, you have the concrete paving machine setting at the center of this span in preparation of placing the concrete over the bridge deck. And here's a photo showing one of these composite tub girders being offloaded from a truck. You can see the camber there at the top of the girder. As you might expect, a lot of the rigidity of the overall superstructure comes from having the bridge deck in place over the girders. So during construction, before that's happened, the overall structure could be more vulnerable to mishap. So you see a picture of these shear studs where the bridge deck connects to. In the future, if you need to replace the bridge deck, you can remove the bottom of those connectors below the girder and then just peel the bridge deck off and replace it. So construction sequencing is one suspected issue associated with this bridge collapse. Another, as I alluded to in the previous video, is there are numerous mentions of damage and repairs to these composite girders on the Maine DOT website for this project. And again, I have to wonder to what extent were well established procedures to identify damage and to repair it and inspect it uh, defined for a project like this. And if there were damaged girders, what caused the damage? How extensive was the damage? Should the girders have in fact been replaced? Those are questions that I ask Maine DOT, and they're not providing any answers at this point. Now, I want to tie in what the overall funding mechanism is for technology like this. The Department of Transportation has a program called ARPA-I, and it's a program to develop advanced technologies for improving the overall transportation system in the United States. And a subset of this ARPA-I program is called XBridge. And it looks like XBridge has provided $23 million to the University of Maine's Advanced Structures and Composite Center, where this composite tub girder technology was developed and then later licensed to Basalt International. The program is pioneering a bridge design approach that utilizes high performance corrosion free materials to replace traditional corrosion prone construction. Well, that's a good goal to have. Corrosion is a multi-billion dollar problem in the United States for bridge infrastructure. Now, this caught my attention. The program is rapidly transitioning from theoretical design to real world validation through full scale prototypes and milestone demonstration projects. Rigorous durability evaluations, including accelerated aging and full scale fatigue testing, are underway to validate a 150-year service life. Demonstration projects are planned to be built over the next 5 years. XBridge is collaborating with state DOTs and the composite industry to explore and overcome barriers to implementation. Well, of course, a potential big barrier to implementation is when you have a catastrophic failure that occurs during construction. Again, we don't know the details. The investigation's ongoing, but I emailed this XBridge director, Miss Severance, and she told me just to reach out to the DOT, and I told her I already had, and I thought as director of XBridge, she might have something to say about the program's future, any thoughts about what happened with the Stillwater Bridge, and I got no response. Now, as part of her presentation, again, linked in the description, the overall process here is to utilize systems engineering to transition into manufacturing, partner with, in this case, Maine DOT, and develop specifications and guidelines. And what a systems engineer's key responsibilities are is they write and translate the client's needs into clear technical specifications. They figure out what needs to be done. They provide systems integration, combining hardware, software, mechanical components into a single cohesive framework. They define the requirements and verification for testing and validation. They define all the aspects of the life cycle management from design concept through production, maintenance, and retirement, and they look at risk and stakeholder management in terms of budgets, timelines, communication between technical and non-technical team members. So they're involved in the process from soup to nuts, as they say. Now, many of you asked in the previous video, how could anyone expect a composite bridge to last 100 years or 150 years? And I still think it's an open question. The short answer is they did modeling. So they subjected these composite tub elements to various environmental and loading cycles. But it looks like the loading cycles were anywhere from 800 hours to 3,000 hours in duration. So that's basically anywhere from 1 to 4 months. And then they extrapolate those results to a 150 or 100-year period. Apparently, the design for these composite tub girders were also done using draft ASHTO guide specifications. ASHTO is an organization of state bridge entities that define design guidance and various aspects of how you design and construct bridge projects. And some of this gets super theoretical, I think unduly so. I've done previous videos about the Francis Scott Key Bridge and how anybody with a lick of common sense would have realized how vulnerable that bridge was to ship impacts. And ASHTO's response, even though that they knew of these vulnerabilities for existing bridges, came up with design guides back in the 90s that were heavily probabilistic, and they decided to apply it to new bridge construction. And in the aftermath of the Francis Scott Key Bridge, now people are looking at applying it to existing bridges, which should have been done all along, but it's kind of a silly, in my view, probabilistic approach. It could have some value in overall risk assessment, but it shouldn't be the final word in determining what you need to do to protect your bridge, because it has things like estimating the size of a ship 20 years from now. I mean, that could be a problem. How much ship traffic you're going to have, the odds that a ship could go off course. And you go through this whole statistical process to determine the risk assessment for a given bridge. And I prefer or would recommend a more resilient approach, and basically design a bridge. If you think it could get hit by a ship, an errant ship, for whatever reason, design the bridge such that that can't physically happen. In this situation, you've got a heavily probabilistic approach. They apparently took experience with fiber reinforced polymer wrapped bridge columns for seismic retrofit and applied it to this composite tub technology. I don't know how well you could model the effects of transportation and construction. You know, these are new technologies. I'm all for new technology. I think the U.S. needs to be more innovative, particularly for infrastructure projects where I make a living. But also, there has to be an appropriate level of risk that's assigned to it. I mean, if you look at a risk matrix, you shouldn't be using a new technology that has a potential for catastrophic failure. You would expect maybe a nuisance level or uh, a lower level of risk that produces a nuisance and maybe has to be repaired or replaced in a period shorter than you had planned for. But having the possibility of a catastrophic failure shouldn't be one of the options, in my view. Now, one thing to note, this technology is being promoted because they say you're going to save all this money in maintenance over the design life of the structure. Now, this was sent to me by a viewer. This is the patent application for this composite tub girder system. This was patented in 2019. Now, if you read the background of the patent, the rationale is to have lighter weight compared to steel or reinforced concrete girders to make them easier and more efficient to transport and to install using smaller cranes at a construction site. There is zero mention of improved corrosion resistance or longer lifespans anywhere in this patent application. Just thought that was interesting. I mean, generally, I thought you tried to make patent applications as broad as possible to cover as many use cases for your claim. As part of this presentation that I've referenced, there's a link in the description. There's existing bridges that were constructed using this composite tub technology, including in Rhode Island in 2022. And I think potentially that's the other shoe to drop. Most likely, the problem that led to the collapse of this span at the Stillwater Bridge is a construction phase issue that hopefully won't create a question about the safety and reliability of these existing bridges that are already in place. But I've got a large audience in Rhode Island, so we'll see how it happens here because there's potential implications for you all here. But this technology could really benefit a state like Rhode Island, where they tend to let their bridges corrode into oblivion. And you have to look no further than the Washington Bridge in Providence. But I'll continue to follow this story. If any of you have any information that you would like to share with me, because I think getting information through official channels is going to be a lengthy process, and I question the level of transparency that we may ultimately see in this situation. Hopefully, they'll come through and provide full disclosure in a timely fashion. But to the extent that you have information that you would like to share, this is my email address. Reach out to me. I'll hold your information in confidence unless you would like to have me acknowledge you as a source of that information. With that, I'm going to do a quick book mention, Lolly Willows by Sylvia Townsend Warner. I really like this book. This book was published in 1926. In essence, to me, it's about a person who doesn't follow the conventional path and doesn't follow the path based on expectations of others, particularly other family members in her life. And has some interesting elements to it, some pretty funny moments in the book, too. It's a book written about a period in the interwar years between World War I and World War II in a setting that I typically don't engage in with a book. So I really liked it. And if you're so inclined, I've got a link in the description. With that, I'd like to send a shout out to those of you who've contributed to Buy Me a Coffee. That's one of the better ways to support this channel. I also want to thank the channel members who typically preview these videos 1 or more days in advance. And of course, I'd like to thank those of you who've contributed to Super Thanks. So stay tuned, everyone.